Okay, so to continue on with what we started yesterday, we are going to solve these triangles, or solve for the parts of these triangles, so solve for the side lengths. So yesterday in our notes, we set up these equations. Today we're going to solve these equations. So to solve the equation, sine of 54 is equal to w over 17. I'm going to solve this, and I'll use a different color. I'm going to multiply both sides by 17. So I want to explain how to do this in your calculator. So in your calculator, what you're going to do is you're going to find the sine of 54, and you want to make sure that your calculator is in what's called degree mode. So degree mode is, on your calculators, usually there's a D or an R at the top, and you want to make sure that that mode says D or DEG. So if you need help changing that, I will help you with that. But what you do is to take the sine of 54, you click the sine button, and you do 54, and then you hit equals, you get that number. You take that number, which is a decimal, and multiply it by 17. That is the length of this side to the nearest tenth. This would be 13.8, okay? 13.8. For part B, it's a little bit different because the variable, instead of being on the top, the variable's on the bottom. So to solve this, you could do this a few different ways. I'm going to show kind of a way that's a little confusing at first, but it'll make sense in the end. I'm going to start actually by multiplying both sides by w. So this becomes w times tangent of 28 equals 1. So to solve this, I'm going to divide 1 by the tangent of 28. So in your calculator, you've got to type 1 divided by the tangent of 28. And in the end, that ends up being 1.9, if I'm rounding to the nearest tenth, okay? Last equation, cosine of 33 equals w over 4.5. I would multiply both sides by 4.5. Cosine of 33, so cosine of 33 times 1.5, which that ends up being 1.3 if I'm rounding to the nearest tenth. So rounding to the nearest tenth is just one decimal place. So moving ahead, and we are just going to set up the equations in this guided practice. So I want you to pause the video. I want you to try just to set up these three. You don't have to solve for anything, but just set up a ratio for each of these three. And then I'll have you practice just setting up the ratios. So the ratios here in part A, the sine of 36 is the opposite side 10 over the hypotenuse x. Part B, sine of 28, or you could have used cosine of 62, because 50 is opposite from 28, but it's the adjacent leg to 62. Regardless of either of those things, x is still the hypotenuse. And then in part C, 10 is the opposite side, or 10 is the opposite leg, x is the adjacent leg. So right now, you're ready to just move on to the practice. You're doing 1 to 22. They're fairly simple problems where you just set up the ratios. The next equations are pretty much the same, except all of these equations, the variable's on the bottom, which I think is good because those are the tougher equations to solve. So to solve sine of 36 equals 10 over x, again, I like to multiply both sides by x because then to solve this, I'm going to divide both sides by the sine of 36. So this is going to be 10 divided by the sine of 36, which if I'm rounding to the nearest tenth is just 17.0 because the decimal is 17.01. I wouldn't round that up, okay? So you get some of these problems, and basically what's going to happen is you're either going to have x on the top or x on the bottom when you write your ratio. If x is on the top, you would multiply both sides by the number that's on the bottom of that fraction. If x is on the bottom, you end up taking that number, so in part B, I would take 50 to solve this, 50 divided by the cosine of 62, or 50 divided by the sine of 28. Either way, the hypotenuse, x, ends up being 106.5. And it doesn't matter which equation you used. So I could do x equals 50 divided by sine of 28, or x equals 50 divided by cosine of 62. Either way, it's the same answer. Part C, to solve, I'm going to take 10 divided by the tangent of 25. So rounding that to the nearest tenth, it's 21.4. So essentially setting up the equation and then deciding, are you multiplying or dividing to solve? So that's how you solve for a side of a right triangle using trigonometry. Now, to find the measure of an angle, it's a little bit different. We still set up the ratio, but in these I'm going to circle the reference angle. So we're trying to find the measure of angle x. So in part A, I'm going to circle x, and it's understanding that 6 is opposite, 10 is the hypotenuse. So I'm going to use the sine of x equals opposite over adjacent, 6 over 10. So to solve this, you're going to take the inverse sine, and it's going to be a button that looks like this on your calculator, sine to the negative 1. So x is really the inverse sine of 6 over 10. So again, that function in your calculator, I'm going to have to help you find that, or help you use a calculator that will work to help you find the measure of an angle. So if you put that in right, the angle measure is going to be 37 degrees if I'm going to the nearest degree. So that's the nearest whole number for the nearest degree. Right? In part B, finding the measure of x, that's our reference angle. 15 is adjacent, 20 is the hypotenuse. So this would be the cosine of x is 15 over 20. So x is really what's called the inverse cosine of 15 over 20. So when you punch that into your calculator, inverse cosine of 15 divided by 20, angle x ends up being 41 degrees to the nearest tenth. So I should have put angle, measure of angle x. Measure of angle x is 41 degrees. So it's that inverse function. So to solve for a side, use regular sine, cosine, tangent. Finding the angle, measure of an angle, use the inverse sine, inverse cosine, inverse tangent. So in example 3, to find the measure of angle y, we're going to circle y. That's our reference angle. 100 is opposite. 41 is adjacent. So we're going to use the tangent of y. And that's going to be equal to opposite over adjacent, 100 divided by 41. So the measure of y is equal to the inverse tangent of 100 divided by 41. And again, I will help you find these measures, or find these buttons on your calculator to help you find these measures. So the inverse tangent of 100 divided by 41 is, to the nearest degree, 68 degrees. So again, I will help you with the calculator side of this, but it's mostly setting it up and finding that button in your calculator and finding the inverse to find the measure of an angle. So I know that was guided practice, but I just wanted to go through that to show you another example. Part B also, I'm just going to go through, because the practice should be enough to kind of help you guys understand what's going on. If the practice isn't enough, I'm posting the IXL practice, because that can be a help when you're reviewing, when you just need some extra practice, or if you need to retake a quiz. So just to explain part B, it says, suppose you know the lengths of all three sides of a right triangle. Doesn't matter which ratio you use to find the measure of any of the three angles. And my answer to that is really no, as long as it's set up correctly. And I'll give you an example. I'm just going to draw a right triangle. And I'm going to give that right triangle just A, B, C. And I'm going to use simple numbers. I'll use 3, 4, and 5. So to understand how this works, I'm just going to pick on angle A, right? I'll use yellow just to highlight that. It doesn't matter which ratio I use, as long as I set up that ratio correctly. So to find the measure of A, I could use the ratio for sine. Sine of A, opposite over hypotenuse, would be 4 over 5. And I could use that to solve. I could also use the cosine of A. That would be adjacent over hypotenuse, which would be 3 over 5. If I wanted to use tangent of A, I would have to do opposite over adjacent, which would be 4 over 3. No matter which one I use, I'll get the same measure for A, as long as I set up the ratio the right way and I plug in the inverse the right way in my calculator. So to find an angle, use inverse trig button. And I will help you find that button if you need me to. So I just want you to focus on the practice right now. It's going to be a paper practice. The IXL is there just as a supplement to help you in case you need to further some practice or get some more practice to feel comfortable on the checkpoint. Finish the lesson out by doing the checkpoint at the end, short Google form, multiple choice.